Hi, in this video we are going to talk about struct in C and C++. We have talked about basic data types so far like long, int, char. In many situations, we would like to store composite objects. For example, a point in a 2D coordinate system, which has two members, x and y, which represents the x coordinate value and y coordinate value. As another example, we would like to store a student's information at one place. For example, a student's roll number, student's name, address, etc. One more example, a web page. You would like to store the URL of this page as a string. You would like to store the number of views on this page as an integer value. You would like to store the content of this page as a string or maybe other information. So to handle these situations, we have structures in C and C++ which allow us to store multiple items together. These multiple items can be of any data type. They don't have to be all of same data type. One member can be char, other member can be int, then the third member can be string or any other thing. Here is an example of a structure. Please note that structure is also called user-defined data type. User specifies how these members are going to be stored and what all are going to be there as a member of the structure. For example, in this structure, the order in which we write these members, they are stored in same order in memory. X is stored first and then Y is stored. Now we create a variable of the structure. This user-defined data type point, we create a variable of it using struct point p. Please note that writing this struct keyword is optional in C++. It is optional in C++, although it is mandatory in C. So in C++, we can write this line as point p, right? We can simply remove this part, right? We access members of a structure using dot operator. We get the member x using p.x. We get the member y using p.y. Here I have assigned values to these members. p.x is assigned 10, p.y is assigned 20. And here we are printing these members. So the output of this program is 10, 20. In C language, we many times use type def with structures. The purpose is to avoid typing that much long. Struct and then struct name, then the variable name. Here is an example of type def. I have created a structure point and I have created an alias for this data type p. So instead of writing struct point everywhere, I can simply write p. So if I create p and then small p, it creates a variable of struct point type. And then I can access p.x, p.y, and I can print them. So the main idea to demonstrate in this program is you can shorten typing this long thing in C programming language. In C++, you can anyways just write point. You do not have to use the struct keyword. So here you can either use struct point or you can use only point if you're programming in C++, or you can use p because you've created a type def for this particular data type. Output of this program is 10, 20 again. Here is one more example program. Here we have a student structure and this structure has roll number as integer, name as a string, address as a string. We create an object of this student or a variable of the student this way. This time we have used a different style to initialize the members. We can initialize the members using these curly brackets and writing the values of these members one by one. We must write these values in the same order as they appear in the student declaration. So first value is assigned to the first member, second value assigned to the second member, third value assigned to the third member. So you get the output as 101, ABC and XYZ. Here is one more way to initialize structure members, and this way is called designated initialization. I have created a point variable p and then I have used member names, and before the member names I have used dot. So I've initialized y as 120 using dot y equal to 120 and initialized x as 100 using dot x equal to 100. You can notice that this order is different from the order in which they are declared. X is declared first and then y is declared. So with designated initialization, we can change the order. We can assign the members in any order by writing the member names. In fact, we can skip some initializations. I can skip the initialization of x. What happens when you skip an initialization? X gets a default value, which is 0 in case of integers. Now if you run this program, you are going to get 0 and 100 because we have initialized y using designated initialization, but we have not initialized x. So we'll have default value of x. Please note that if we do not do any initialization of structures, like if I remove this line completely, then I'm going to get some random values, right? I won't get the values as 0, 0. We get the value 0 only when some members are initialized using designated initialization and some members are not. Also, this is a C style construct. It might not work in C++. You may get compiler errors in C++ compilers when you try to write a construct like this. Struct is mainly a C style construct. It was added to C programming language to support composite data types which have multiple members. Since C++ programming language supports almost everything which C supports because of backward compatibility, structures were included in C++ also. Please note that C++ has a construct called class. We can do almost everything that we can do with a struct. So structures in C++ are kind of redundant, but we still use them. We'll cover the differences between classes and structures in a separate video.